Welcome to Math 097 Lecture 29. Today we're going to be looking at Section 10.1 about solving linear inequalities in one variable. Now, as you look at handout 29, the first thing that I've listed there is that there are in fact two notations that are acceptable for final answers for this section. The first one is called interval notation, and what I've done is given you a list of 4 bulleted items that describe some of the things you need to think about when you're using interval notation. You might want to go ahead and pause the video and read through those 4 bulleted items now. The second item then is called set builder notation. And for set builder notation, you're going to see that I've given you an example and then I have described all the different parts that make that happen. So the first thing you draw when you're doing set builder notation is a curly bracket, and that would be the set of. And then next door to that, you write down the variable for the problem, in this case x, and you could read that as all elements x. And then next door to that, you draw a vertical bar, and that vertical bar is read such that. And then after the vertical bar, you write down some kind of property that x is supposed to demonstrate. So maybe x is supposed to be greater than 7, or x is going to be a real number. You would write that kind of information in that spot. So now that we have an idea of what those notations are, let's go ahead and check out some examples. Now, what I've done is given you a table where I have drawn a graph on a number line, and then I want to talk about interval notation and set builder notation for each one of those graphs. Now, what I'm going to choose to do is go through and fill in the interval notation for all 3 of the examples first, and then I'm going to come back and talk about set builder notation. So let's start with our first graph, interval notation. So for interval notation, in order to demonstrate the idea that there are going to be 5 different parts for interval notation, on the board, I'm going to go ahead and draw 5 little underlines. Now, when you're looking at those 5 pieces, I'm going to start this time by talking about them kind of out of order. I'm going to start in the middle. So the third of our 5 items for interval notation is always a comma. So now let's go ahead and fill in the rest of these pieces. So you saw just a moment ago in the bulleted list for the interval notation that you always travel left to right when you are working with interval notation. So I want to go left to right and write down the first number or idea that I encounter as I travel left to right. In this case, the first number that I encounter on this graph is the number 1. So my second item in interval notation is going to be that number 1. Now I'm going to continue going to the right and then ask once again, what is the last number or idea that I encounter as I go left to right? The last number that I encounter in this particular problem is the number 3. So I'm going to put a 3 right there in spot 4. So now I have to fill in my last 2 spots, spot 1 and spot 5. So over here on the left-hand side, what I have to decide is whether I'm going to put a parenthesis or a square bracket next door to this 1. And it all comes down to whether we're going to include that 1 in interval notation or not. Well, in order to answer that question, we need to go back to the graph and figure out whether we're including or not the number 1 graphically. So as you look at the number 1, notice that we have an open circle there. An open circle on the graph means that we are not including that endpoint of 1. So if we're not including that endpoint of 1 graphically, we don't want to include it in interval notation either. So that means we're going to use a parenthesis next to that 1. Well, on the other side, when we look at the 3, we have to do the same thing. So next to this 3 in spot 5, I'm either going to have a parenthesis or a square bracket, and that's going to demonstrate whether we have included or not that endpoint. So picture-wise, we have a solid dot. That means that we are including it on our graph. So we need to demonstrate that down here in interval notation as well. I'll use a square bracket to demonstrate the fact that we are including that endpoint of 3. So now, a moment ago, I put those 5 underlines on the board just to demonstrate the fact that there were 5 items. In general, you don't write the underlines. So the interval notation here is parenthesis 1, comma 3, square bracket. Well, now let's go ahead and move to our second example. As you look at that second example, remember once again that we're always going to travel left to right. So the very first thing that I notice as I travel left to right is this idea that we're going forever to the left. So if I'm going to go forever to the left, I need to have a symbol that describes that idea. A lot of people have seen the symbol infinity, but if I put a negative in front of that, that means we're going forever to the left. Well, now I have to decide how to move on from here. This time I'm going to go ahead and decide whether I'm going to put a square bracket or a parenthesis first, and then I'll move on with the interval notation. One of the bulleted items that I have listed above is that you will never use a square bracket for an infinity or a negative infinity. You'll always use a parenthesis. So I'm going to go ahead and put the parenthesis and then comment about why we'd never use that square bracket. If you were to put a square bracket next to this negative infinity, what you're saying is you're going to go to the number negative infinity and then you're going to stop. But negative infinity is not a number, it's an idea. So because negative infinity is an idea, you can never include it, which means you can never put a square bracket next to it. So once again, you'll always use a parenthesis next to a negative infinity. You'll also put one next to a positive infinity. So, okay, let's keep going. Remember, the third item for interval notation is always a comma, so I'll put that comma in there. And then the last number that I encounter on this particular problem is 2, so I'll put a 2. And then I have to decide whether I'm going to include that or not. On the graph, we have an open circle. That means that we are not including 2, so I need to say the same thing in interval notation. I'll put a parenthesis next to that 2. Now that we have the interval notation for the second graph, let's check out the third graph. As you look at that third graph, notice we're going forever to the left, and we're going forever to the right. So forever to the left, we're going to have a parenthesis, a negative infinity, and then that comma. And then forever to the right means we're going to have a positive infinity, and again, parenthesis for that. So at this point then, we have the interval notation for all three of these graphs. So now we're ready for our set builder notation. So let's go back to the first graph and do set builder notation. So remember, once again, set builder notation starts off with the curly bracket to say it's the set of. And then you write down your variable. Well, if you look at the graph, you'll notice our variable is x. So I'll put the x, and then you draw the such that bar. So far we have the set of all x values such that. And then we need to describe the x values that we like. Well, we like the x values between 1 and 3 here. Now, one nice way of writing down any kind of problem that involves the English word between is to use a three-part inequality. Now, the three-part inequality world is in a lot of ways the same as the interval notation world. I'm going to travel left to right when I write this down, and I'm going to go ahead and say, okay, what's the first number I'm counting? 1. And then if I travel left to right, I would do a less than symbol. And then as you look at this picture, notice all of this in between the 1 and the 3, that's the stuff that's colored in. Those are the x's that we're interested in. So the x's are between this 1 and the 3. So once again, a three-part inequality is a nice way of demonstrating any kind of picture where you can say that you were looking at things between two numbers. Now, before I move on from these inequalities, I need to be kind of careful about this because right now I have strict inequalities. Those two strict inequalities means that I'm not including the 1 and I'm not including the 3. That actually doesn't follow with my graph. So once again, as I look at my graph, notice that we have the open circle on the 1, which means we are not including the 1, so I'll leave that as a strict inequality. But over on this other side, we are including the 3. Once again, that's colored in. So because we're including that 3, I need to change the symbol so we have the equal to. So now we have an inequality that describes this picture. The only thing that's left is to put the curly bracket on the right-hand side to finish off my set. So I'm going to read it from left to right. This is the set of all x values such that x is between 1 and 3, including the 3, and then we put the curly bracket on the right-hand side. So now that we have that then, let's go ahead and see what we can do with some of the other problems. So second graph then, once again, it's going to be the set of all x values such that. This time, however, we don't have a between picture. We have everything to the left of 2. So I need to write down an inequality that describes the idea that we are to the left of 2. Well, an inequality that would describe being to the left of 2 would be x is less than 2. Now again, you always have to ask yourself, should we put the equal? And the answer on this one is no, because we have an open circle at that 2. Go ahead and put the ending curly bracket, and there we have our answer. The set of all x values such that x is less than 2. And then our final example then, what happens if you have everybody colored in? In order to describe that one, we actually need to write down some more words. So this time, I'm going to go ahead and slide down to the bottom for this part of our answer. The interval notation is already up there, so the set builder notation is going to be the set of all x values such that. And sometimes people try to come in and say, let's use the infinities on an inequality. In general, in set builder notation, you don't use infinities. So we're going to have to use words. And the words we can say is x is a real number. So the set builder notation to describe everybody on the number line being colored in is the set of all x values such that, and then we have to write it in words. X is a real number.